Hi guys, welcome to another physics video. I'm Akshata, your instructor, and I'm part of KARMANT Learning, which is a wonderful nonprofit organization. Today we'll be going over kinematics, which is basically a problem-solving approach to whatever we've covered so far. Now that we've covered most of the basics of introductory motion, it's time to solve the problems. In your physics classes, you'll be expected to solve a lot of problems relating to velocity, acceleration, and displacement. Before moving on, why don't we review? Position is the location of an object relative to coordinate axis. So let's say we have a coordinate axis here, that's 0, and this is our object. So its position would be the distance from 0 to its position, basically. Now next, displacement. Displacement is the change in the position of an object. So final position minus initial position. And I hope you guys remember velocity, which is the change in displacement over time. So it would be the final displacement minus the initial displacement all over time. So it's the rate of change of displacement. And lastly, acceleration is basically the change in the velocity over time. So like how we got velocity earlier, it's final velocity minus initial velocity all over time. So here are our big list of equations. These are the only equations that you will need, at least in introductory kinematics problems. And I know they look like a lot of symbols and variables and constants, but don't worry, these are all familiar. So as you can see, v is our final velocity, v naught, or v with a subscript of 0, is our initial velocity. And next is t, which basically stands for time, and we've seen that before. Acceleration is denoted by a little lowercase a. And finally, the delta x you see is basically the change in displacement. Instead of describing these quantities, now we're going to solve for them. If you're wondering how we got to these equations, most of them were derived from calculus methods. Usually that stuff is not covered in an intro physics course. Anyways, most of these equations features many variables, and one of which you'll have to solve for. For instance, you'll be given 3 variables, and you'll have to solve for the 4th one. It's really easy to get lost in all the different variables in a problem. What I recommend is that you sort out which variables you already have, and then which variables you need. It helps to make a known/unknowns list. So for instance, if you are given a problem, you put the known variables like v, v0, and t, and whatever you want to solve for in the unknowns. And that helps clear things up. It's also really helpful to actually understand the equations instead of just see them as a mass of variables and numbers. So this equation, v is equal to v0 plus at, gives you the final velocity of an object that is accelerating. So you can use it when you're given 3 out of 4 variables. Like for instance, you're given v, v0, and a, and then you can find t, or any combination of 3. Our next equation relates the total distance or displacement traveled to your final velocity, the time, and the acceleration. For instance, if you know the time traveled, the final velocity of the object, and its acceleration, this equation will give you the change in displacement or the total distance traveled. Also, note this equation is a quadratic. If you are solving for the time, then you must apply the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This equation is one of my favorites. It does not include time. If you can see, there is no time variable. So basically, this equation relates the final velocity squared equals the initial velocity squared plus 2 times the acceleration times change in displacement. So this equation is especially helpful if you don't know the time period or don't want to bother solving for it. It's a quick, direct way to solve for other variables without complications. And finally, this is the average velocity equation. It is one of the least common, as most textbooks leave it out, but I find that it's still important if you want to make a calculation but don't know the acceleration. As you can see, there's no acceleration in the equation. So this equation relates the displacement traveled to the average velocity, which is v plus v0 over 2, multiplied by the time variable. Now we're going to move on to practice problems. If you feel that you didn't quite understand the concepts of the other equations, I recommend you go back to the video or review some of the older concepts. If not, then let's get started. A car is traveling at 10 meters per second. It travels for a displacement of 40 meters with an acceleration of 2 meters per second. What is its final velocity? Okay, so the first thing we want to do is take note of our variables and make a knowns and unknowns list. So the knowns list will feature the variables that we already given, and its unknowns is what the variables that we desire. So we know that v0 is 10, acceleration is 2, and our displacement is 40. And what do we want to find? We want to find our final velocity. Okay, here's the big question. So now what equation do we use? What I recommend is that you glance over your knowns and unknowns list and match up which quantities you do know to some of the equations that we covered before. So we know v0, a, and x. So the equation that matches the most is v squared is equal to v0 squared plus 2ax. And now what we have to do is solve for the v squared using basic algebra. So if we solve for the v squared, we see that v is equal to the square root of v0 squared plus 2ax. I recommend first solving for the variables in the variable format and then plugging in the numbers like I'm doing right now. So we have the square root of 10 squares plus 2 times the 2 times 40. And then our final result will be about, I think, 16.2 meters per second. Let's work on another problem. You push a brick on an ice skating rink with an initial velocity of 5 meters per second. You see that it travels 20 seconds and then stops. What is its acceleration? So the first thing we have to do is make a knowns unknowns list. In the known, we would have to put our initial velocity, which is 5 meters per second, and then our t of 20 seconds. Do we know the final velocity? I think we do, because it says that the object stops. So that automatically means that the final velocity is 0 because the object's not moving. Okay, and what is it that we want to find? We want to find the acceleration of the object. So looking at our unknowns and knowns list, and then going back to the equations, we can see that v is equal to v0 plus at matches the most. And solving for a, we get v minus v0 over t, where we finally sub in all the values, and we get 1/4 meters per second squared. So the problems that we just did were all in one dimension. All of our problems will be in one dimension for now, but the ones that we did before featured only x direction motion, like to the left and to the right. Now we're going to move on to vertical motion. Basically, this motion is called free fall. It's either falling objects or objects that are thrown up. And I want you to note that free fall has an acceleration of g, which is 9.8 meters per second squared. And this 9.8 meters per second squared is always pointed downward, so it is negative. Let's do another problem. You throw a ball at a velocity of 10 meters per second. When does the ball reach the top of its flight? It seems like this problem barely gave us any information. But let's still make our knowns and unknowns list. So first we are given that the initial velocity is 10 meters per second. And we have to find the time, or when the ball reaches the top of its flight. There's a hidden 0 in this, so we know that our final velocity is actually 0. And why is this? This is because at the top of any path, the y velocity of any object is always 0, so it's temporarily not moving. And this is a key fact to solving this problem, because if you didn't know it, then you'd be off in the wrong direction. So now that we know the final velocity, the initial velocity, and we know that our acceleration is g, as mentioned before, negative 9.8 meters per second, we can begin solving. So v is equal to v0 plus at. Solving for the t, we see that t is equal to v minus v0 all over a. And after subbing in all the values, we can see that t is 10 over 9.8, so negative 10 over negative 9.8, which gives us a time of about 1 second. So that's it for today. So today we covered all of the kinematics equations, problems, and a bit of freefall. If you enjoyed this video, please like and subscribe to our channel. Also hit that notification bell. If you have any suggestions or questions on contents of this video, please email info@karmantlearning.com.